in continuation with our assignment problem topic, the next question is related to unbalanced maximization type. Let's read the question. A consulting firm estimated the sales revenue in millions of Indian rupees per month for 5 types of departmental stores: shoe, toy, auto, houseware, video, in 4 locations, A, B, C, and D, of a city for a chain store operator. What type of departmental store is more suitable for a location so that the total revenue is maximized for the firm? So that means whatever are the cell entries, those are all revenue in Indian rupees per month. Okay. And there are 5 departmental stores which are possible and 4 locations are possible. It's very clear that since it is 5 and here it is 4, it is an unbalanced assignment problem. I can say this is an unbalanced AP assignment problem. Why? Since number of rows is not equal to number of columns. So that is the first thing what we saw from this question. And then since all these cell entries are related to sales revenue, that means the firm is interested in maximization of the same. Not only that, here also they mention total revenue is maximized. So the given problem is of maximization type. So primarily we have to convert the problem, given problem, into a balanced problem. Number of locations are 4, whereas number of department stores are 5. That means in order to make it a balanced one, I need to bring in one dummy column or a dummy location. That is the first step. With all the cell entries, whatever may be the cell entries, that will be zeros. So 10, 6, 12, 8, and 0. This is what? This is balanced assignment problem. You are converting it into a balanced assignment. Balanced AP. Second row, 15, 18, 5, 11, and the last entry will be 0. This is our dummy location. I will call it as DU. And let me write here the notations. Sorry. Instead of writing that, I'll write A, B, C, D, E. Sorry, not E, it is a dummy one. And this is what we are doing in the first step, is making it as a balanced AP. Okay. Then the third row, 17, 10, 13, 16, and 0. Then fourth row, 14, 12, 13, 10, and 0. 14, 16, 6, 12, and 0. So these are the 5 departmental stores. Right. First we made it as a balanced AP. Then since it is a maximization type, in order to apply the Hungarian algorithm, we need to first convert this into a minimization type. How do we do that? We will choose the maximum cell entry here among all this. We may notice maximum is 18. Now subtract all the cell entries of this matrix with the maximum. Means 18 minus 10, it becomes 8. 18 minus 6, it is 12. 18 minus 12, it is 6. 18 minus 8, it is 10. 18 minus 0 is 18. Then 18 minus 15, 3. 18 minus 18, 18 minus 5, 18 minus 11, 18 minus 0. So the last column, everything will be 18 only. 18 minus 17, it's 1. 18 minus 10, it is 8. 18 minus 13, it is 5. 18 minus 16, it is 2. 18 minus 0, 18. And then 18 minus 14, 18 minus 12, 18 minus 13, 18 minus 10, 18 minus 0. This is 4. This will be 2. This will be 12. This will be 6. And this will be 18. Right? So what is this actually? It is opposite of your revenue matrix, which means I can call this as an expense matrix. I'm just considering opposite to revenue as expense. Yeah. So now that it has become an expense matrix, it becomes a minimization type now. Minimization type, because we will be interested in minimizing our expenses. So once you brought the problem to a minimization type, we can start using the Hungarian algorithm. The first step of Hungarian algorithm is row minima reduction. Means identify the least in each row, subtract all the elements from its least, with its least, right? Not from its, with its least. Means here the least is 6. So 8 minus 6, 12 minus 6, and 6 minus 6, 10 minus 6, 18 minus 6. Then next row already 0 is there. So even if I subtract it with the least, which is 0, no change in the elements. So I will write as it is 3, 0, 13, 7, and 18. Then the next row, the least is 1. So I have to subtract every element with 1. First one will become 0. 8 minus 1, it is 7. 8 minus 5 is 3. 8 minus 2 is 6. Oh, I'm sorry. Least is 1, right? Least is 1 means I have to subtract everything with 1. First one is okay. This is wrong. This is wrong. Sorry. Now, 5 minus 1, it is 4. 2 minus 1 is 1. 18 minus 1 is 17. Here the least is 4. So everything you subtract it with 4. 0. This will be 2. This will be 1. This will be 4. This will be 14. Here the least is 2. Subtract everything with 2. First one will become 2, then 0, then 10, then 4, then 16. We got the reduced matrix based on row minima reduction. Then the next step is column minima reduction. Same thing, whatever we did in row, that has to be done for the column. First column already 0 is there, so no change in the elements. 2, 3, 0, 0, 2. Second column also has a 0 in it. So 6, 0, 7, 2, 0. Third column also has a 0 in it. 0, 13, 4. I am writing the same because even if you subtract, the numbers will be the same. Because least is 0. Right? Next column, the least is 1. So this will become 3. This will be 6. This will be 0. This will be 3. And this will be 3. Then the next column least is 12. So that means first element will become 0. Then this will become 6. This will become 5. This will be 14 minus 12. So it is 2. 16 minus 12, it is 4. We got now the reduced matrix column minimum. What next? Next is to review each row and identify whether any presence of single 0 is there or not. First row, does it have a single 0? No. So we will ignore for the time being. Next row, is there a single 0? Yes. We will assign it. Since I assigned in this position, any other 0 in that column needs to be crossed. So I will cross this. Third row, more than 1 0, ignore it for the time being. Fourth row, single 0, yes, assign it. Since I assigned here, any other 0 present in that column should be crossed. So I will cross this. Last row, there is no 0 present, so ignore it. Come to column reviews. First column, assignment already done. Second column, assignment already done. Third column, there is a 0 present, assign it. Since I assigned in this position, any other 0 present in that particular row needs to be crossed. So I'll cross this 0. Fourth column, is there a single 0? Yes, assign it. Last column, there is no 0 present now. So we have to ignore. Once again, row review, already assigned, already assigned, already assigned, already assigned, no 0 present to assign. Same way for columns, assigned, 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 no 0 present. What is the next step? Tick all unassigned rows. The last row is unassigned, tick that. If a row is ticked and if it has or had a 0 in it, it had a 0 in here, then tick the corresponding column. I'll tick this column. If a column is ticked and if it has an assignment, yes, it has an assignment here, tick the corresponding row. Again, a row is ticked, has a 0, tick the corresponding column. Row is ticked, had a 0, tick the corresponding column. Column is ticked, has an assignment, tick the corresponding row. So it is getting repeated. That means no more ticking is possible. Next step, draw lines through unticked rows and ticked columns. Unticked rows, there are the first row unticked, then the third row and fourth row. These are the rows which are unticked. Okay. And then ticked column, only one column is ticked, which is the second column. I'm going to draw a line through that elements. Right. After doing that, after doing this line drawing procedure, what is the next step? Identify the least element where no line is passing through and call it as theta. So here, theta is what? Let us check the elements. 3, 13, 6, 6, 2, 10, 3, 4. You need to check those elements where no line is passing through. The least is 2. So I will say theta is. Then what is the next step? Next step is to next step is to form a new matrix. Let me form a new matrix. Okay. Now, what is to be done? Wherever single line is passing, you have to retain. Wherever two lines are passing, you need to add theta. Wherever no line is passing, you need to subtract theta. So here 2 will remain as 2 because single line passing. 6, you will add it. So 2, 8. First element will be 2. Second element will be 8. Okay. Then 0, 3, 0. It will retain as it is. 0, 3, 0. Then the second row, no line is passing, you have to subtract theta. So 3 will become 1, 3 minus 2, 1, 1, 0, 11, 1, 0, 11. Okay. Then this will become 4 and 4, 4 and 4. Then the third row, 0 will be 0 only because you have to retain because single line. Here 2 lines means it will add means 0, 9, 4, 0, 5. 0, 9, 4, 0, 5. 0, 9, 4, 0, 5. That is our third row. Then fourth row, 04132, 04132, 04132, because this 0132 single line is passing, so I'm retaining. Only this two lines are passing, so I'm adding theta. So 2 plus 2, it became 4. That's what I wrote there. Here, all these numbers do not have a line. That means I should subtract. Here, single line, so I should retain. So it will become 008, 008. Okay. Then this will become 1, this will become 2. 1 and 2. 1 and now restart doing assignments. For the first row, there are 2 zeros, so ignore it for the time being. Second row, there is a single 0, so assign it. Since I assigned in this position, in the corresponding column, if there is any other 0, you need to cross, so I will cross this 0. Second row, more than single zeros, time being, ignore it. Fourth row, there is a single 0, so let us assign it. Since I assigned in this position, any other 0 in the corresponding column needs to be crossed. This and this, I will cross it. Okay. Then last row, there is no 0 present to assign. Now come to column reviews. First column already assigned, second column already assigned, third column, there is a single 0 present, assign it. Since I assigned it here, any other 0 present in that particular row needs to be crossed, so I will cross this 0. Fourth column, there is a single 0 present, yes, assign it. Last column, there is no 0 present, you can't do assignment now. Again, restart with our ticking process. Tick all unassigned rows. This one. If a row is ticked and if it has or had a 0 in it, it had a 0 here, it had a 0 here, tick the corresponding columns. If a column is ticked and has an assignment, tick the corresponding row. If a column is ticked and has an assignment, tick the corresponding row. Right. One more thing I missed to tell you. Number of rows we could draw is here 1, 2, 3, 4. 4, and we could get 4 assignments. It was matching. Every time after drawing lines, we need to check that. Now, for this, draw lines through unticked rows. So there are 2 rows which are unticked. Let us draw lines through that. And ticked columns. There are 2 columns which are ticked, first and second column. Let us draw lines through that. Yes. So we could draw 4 lines, 1, 2, 3, and 4. That means we also got 4 assignments. It was matching. Now what? Form a new matrix again. Let me form it here next to this. Now, what is theta? You have to identify here. Theta is the least element where no line is passing through. 11, 4, 4, 1, 3, 2, 8, 1, 2. So theta is 1. Now, wherever 2 lines are passing through, add theta. Wherever single line is passing through, retain. Wherever no line is passing through, you subtract. So first one, 2, there are 2 lines passing. I need to add. 2 lines passing, I need to add. Single line, retain, retain, retain. Single line, retain, retain. No line, that means I have to subtract, subtract, subtract. 2 lines, add. So 0 plus 1 becomes 1. 9 plus 1 became 10. Then this one, retain, 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 subtract, subtract, subtract. Then retain, retain, subtract, subtract, subtract. Now, restart our assignments. First row, more than single zero, time being ignore it. Single 0% in the second row, assign it. Since I assigned here, any other 0% in that column needs to be crossed. So I will cross this 0. Third row, there is a single 0%, assign it. Since I assigned there, any other 0% in the corresponding column needs to be crossed. So I will cross this. More than single 0, time being ignore it. Last row, there is a single 0 now, assign it. Since I assigned here, any other 0% in the corresponding column needs to be crossed. So I will cross this. Row reviews are done. Now column review. First column already assigned, second column already assigned, third column more than 10, time being ignored. Fourth column already assigned. Last column, there is a single 0%. So we will assign that. Since I assigned there, any other 0% in the corresponding row needs to be crossed. So I will cross this. Right. So column reviews are done. Now again, once again, row review. Already assigned first row, second row already assigned, third row already assigned, fourth row, is there a single 0 now? Yes, assign it. Last row already assigned. We may notice now there are 5 assignments. That is what is our desired, because this order of the matrix is 5 by 5. We got 5 assignments. We got 5 desired assignments. Hence, we can say we reached optimality. So we can stop the algorithm and write the optimal solution. It's basically what these are all locations. I think A, B, C, D, and dummy. And these are all the departmental stores. The first one is what? Shoe. The second one is toy. Third one is auto. Fourth one is houseware. Last one is video. So we can write the optimal solution here. Original problem was about maximizing the revenue, right? So I am supposed to calculate what is the maximum revenue possible by these assignments. First column is assignment, and second column is revenue INR in million. Okay. First assignment shoe is assigned to dummy. So revenue, of course, dummy we had kept it as 0 only. So I can write that. Toy 2. What is the second one? Location B. Then auto to location D. Location D. Then houseware to location C, and then video to location A. Now we can find out the revenue from the original matrix. Toy to B. Toy to B is 18. I can write there 18. Okay. Auto to D. Auto to D is 16. 16 million rupees. And then houseware to C, video to A. Houseware to C, what was that? Houseware to C is 13. Video to location A, 14. Now let us add this. What do we get? If I add 7, 13, 21, 61, means maximum expected revenue is rupees 61 million by doing these assignments. That will be the optimal assignments. Yeah, that is the solution for this particular question. In case if you find the contents of this video to be useful to you, I request you to please like, share it with your friends, and also subscribe to my channel. Thank you.